Have you ever wondered how Saturn got its stunning rings? These celestial circles of beauty, known as planetary rings, are more than just an aesthetic spectacle in our cosmos. They are a testament to the intricate workings of our universe. Planetary rings are composed of countless particles, ranging from tiny, dust-sized icy crystals to larger chunks of rock, all held together by a planet's gravitational pull. While most of us are familiar with the majestic rings of Saturn, you might be surprised to learn that other planets like Jupiter, Uranus, and Neptune also boast these cosmic crowns. But these aren't the only objects in our universe adorned with rings. Some distant and unexpected celestial bodies like Haumea, a dwarf planet located beyond Neptune's orbit, also sport this mystical feature. From their formation to their composition, planetary rings are a fountain of fascinating scientific discoveries. So, are you ready to journey with us into the cosmos? Let's delve into the top 10 fascinating discoveries about planetary rings. Starting our countdown, at number 10 we have the Rings of Jupiter. Now, when we talk about planetary rings, the mind instinctively paints a picture of Saturn. But did you know Jupiter, the largest planet in our solar system, also boasts a set of rings? Yes, indeed. These rings were discovered in 1979 by NASA's Voyager 1 spacecraft. Unlike the ice-filled rings of Saturn, Jupiter's rings are composed primarily of dust particles that have been kicked up by meteoroid impacts on the planet's small inner moons. The Jovian ring system is faint and delicate, almost ethereal in its presence. It stands as a stark contrast to the gas giant's otherwise formidable persona. The ring's dusty composition and faint visibility make them a unique feature among the planetary ring systems. A gaseous giant with a delicate touch, Jupiter's rings still hold many secrets. At number 9 we bring you the arc rings of Neptune. Neptune, the 8th planet from the Sun, is known for its deep blue color and its peculiar rings. Unlike the uniform rings of Saturn, Neptune's rings are clumpy, forming arcs that orbit the planet. The 5 principal rings of Neptune were discovered in 1989 by the Voyager 2 spacecraft, but their existence was suspected long before that. The most fascinating of these are the arc rings: Adams, Leverrier, Lassell, Arago, and Galilei, named after astronomers who made significant contributions to the study of Neptune. The mystery that surrounds these arc rings is their stability. How do these arcs maintain their shape without dispersing into a uniform ring around the planet? This question has puzzled scientists for years. Some theories suggest that the gravitational influence of Galatea, one of Neptune's moons, might be responsible for this unusual stability. These elusive arcs, a testament to the unpredictable nature of the cosmos. Number 8 takes us back to Saturn, home of the E-Ring. Saturn's E-Ring, the second outermost ring of the planet, is a real showstopper. But it wasn't until the 1960s that astronomers finally noticed it. The E-Ring is unique, not just for its sheer size, but also for the icy particles that make it up. The source of these icy particles, you ask? Saturn's moon, Enceladus. Yes, you heard that right. Enceladus, one of Saturn's 53 named moons, is actually responsible for the existence of the E-Ring. The moon ejects icy particles from its South Pole geysers into space, and these particles then orbit Saturn, creating the E-Ring. This discovery has profound implications. It illustrates an intricate cosmic dance between a planet and its moon, a connection that we're only beginning to understand. It also hints at the possibility of life on Enceladus, given the presence of water ice. A dazzling display of cosmic connection between a planet and its moon. Coming in at number 7, it's the Rings of Uranus. Unveiled to us in the late 20th century, these rings were a surprise discovery. Unlike the bright, icy rings of Saturn, the rings of Uranus are dark and unassuming, almost stealthy. They're composed primarily of large chunks of water ice and radiation-altered rock, making them a fascinating study in contrast. The challenge? These elusive rings are incredibly difficult to study. Shrouded in darkness and located approximately 1.8 billion miles away from Earth, they're not exactly easy to reach or observe. Yet they hold invaluable clues about the early solar system and the processes that shape planetary formation. Each of Uranus's 13 known rings tells a unique story. From the dusty Epsilon ring to the outermost Mu ring, these celestial bands bear testament to the cosmic ballet that's been playing out for billions of years. Uranus, a distant enigma with an understated charm. At number 6 we return to Saturn with the Phoebe ring. This is no ordinary ring, it's a colossal structure, approximately 200 times the diameter of Saturn itself, making it one of the largest rings in our solar system. The Phoebe ring is shrouded in mystery, but scientists believe it's composed of tiny particles of dust and ice blasted off Saturn's moon Phoebe. These particles are believed to have been ejected as a result of meteor impacts, forming a faint but extensive ring around the gas giant. What's more fascinating is that the Phoebe ring orbits in the opposite direction to Saturn's other rings and moons. It's a peculiar feature that hints at Phoebe's likely origin outside of Saturn's system, possibly as a captured Kuiper belt object. The Phoebe ring is a testament to the enduring allure of Saturn, a planet that continues to intrigue and mystify us with its complex and beautiful ring system. Saturn, the planet that keeps on giving. Halfway through at number 5 we have the fascinating ring-moon systems. These are the cosmic dance floors of the universe, where planetary rings and their moons engage in a perpetual ballet. You see, moons and rings have a relationship that's a little more complicated than you might think. The moons do more than just orbit their parent planet, they also interact with these rings, shaping and maintaining them in a variety of ways. Take Saturn's moon, Prometheus, for example. As it orbits Saturn, it moves in and out of the planet's thin F-ring, creating waves and ripples that can be seen from Earth. This moon is essentially sculpting the ring with its gravitational pull, making the ring an ever-changing landscape of peaks and valleys. And then there's the impressive shepherd moons. These small moons reside within the rings themselves, clearing pathways and keeping ring particles in check. They are the shepherds of the ring, hence their name, maintaining the order amidst the chaos. But it's not just about shaping and maintaining rings, the moons themselves can form rings. The G-ring around Saturn, for instance, is believed to be replenished by a nearby moon, which sheds material into the ring through a process called micrometeoroid bombardment. The complexity of these ring-moon systems is astounding. It's not just a moon orbiting a planet with a ring around it, it's a dynamic system where moons and rings interact, influence, and shape each other in a continuous dance. They twist, turn, and tumble in response to each other's movements, creating a cosmic ballet that's as beautiful as it is complex. And the most exciting part? We're still discovering new moons and rings and learning more about their intricate relationships. The more we discover, the more we realize how much there is left to understand about these fascinating systems. So the next time you look up at the night sky, remember the intricate dance happening millions of miles away. A cosmic ballet of moons and rings dancing through the ages. At number 4, we explore the Rings of Rhea, Saturn's moon. The cosmic dance between Rhea and Saturn took an unexpected twist in 2008, when scientists uncovered what seemed to be rings encircling the icy moon. This finding, if confirmed, would make Rhea the only moon known to possess a ring system, a feature typically reserved for gas giants. The discovery sparked a flurry of excitement and debate in the scientific community. What could this mean? If moons can have rings, the possibilities for the universe become even more staggering. However, the evidence remains controversial, with some experts questioning the data. Despite the ongoing debates, the potential Rings of Rhea pose an exciting question. Could other moons also harbor such structures? And if so, what processes are at play in their formation? The answers may redefine our understanding of moons and planetary rings. Rhea, a moon that dares to rival its parent planet. Coming in at number 3, we delve into the origins of planetary rings. The formation of these celestial halos has been a topic of mystery and debate among astronomers. The leading theories propose 2 fascinating models, the rubble pile model and the tidal disruption model. The rubble pile model suggests that rings are remnants of a moon or similar body that was smashed apart by a catastrophic collision. Imagine a celestial demolition derby, leaving behind a glittering trail of debris circling the planet. On the other hand, the tidal disruption model proposes that a moon, straying too close to its parent planet, was torn apart by the planet's gravitational forces. Much like a cosmic tug-of-war, the moon loses, breaking apart and forming a ring. Both theories share a common theme. From chaos and destruction, these beautiful, intricate rings arise. So remember, next time you gaze upon Saturn's rings, you're witnessing the afterglow of a cosmic catastrophe. From destruction, beauty arises. At number 2, we have the Rings of Haumea, a dwarf planet. Now, this is a fascinating discovery that truly took the scientific community by storm. We've seen rings around gas giants, sure, but a dwarf planet? That's a whole new ball game. Situated in the Kuiper belt, beyond Neptune's orbit, Haumea is a tiny world that's full of surprises. The most striking of these is its ring system. Yes, you heard it right. Haumea, a dwarf planet, has a ring system, much like the majestic Saturn. This discovery has given us a fresh perspective on the dynamics of our solar system. It's a testament to the fact that even the smallest celestial bodies can hold mighty secrets. Who knows what other surprises are lurking in the far reaches of our solar system? And that's the beauty of space exploration, isn't it? It keeps us on our toes, always eager for the next big revelation. Haumea, a tiny world with mighty surprises. And finally, at number 1, we tackle the lifespan of planetary rings. Planetary rings, those beautiful celestial halos, are not permanent fixtures in the cosmos. Their existence is a delicate balance between creation and destruction, a dance between the forces of gravity and the harsh realities of space. Research suggests that the longevity of these rings is largely dependent on the material they're made of and the environment they exist in. For instance, Saturn's rings, composed primarily of ice particles, are believed to be relatively young, possibly less than 100 million years old. That's a blink of an eye in the grand scheme of the universe. In contrast, the dusty rings of Uranus, darker and less reflective, could be older. The difference in age can be attributed to the processes that erode these rings. Solar radiation, interplanetary dust, and the planet's own gravity can all chip away at a ring system, gradually scattering and diminishing its material. But it's not just about destruction. New material can be added to the rings too. Collisions between moons or with passing comets can replenish a ring system. Even the planet itself can contribute, with volcanic activity or geysers ejecting material into space. So what does this mean for the future of our favorite ring systems? Well, it's a mixed bag. Some rings may dissipate entirely, their material scattered into space or drawn into the planet. Others may survive, replenished by new material or protected by the gravitational pull of nearby moons. The lifespan of a ring is a complex interplay of factors, a puzzle that scientists are still piecing together. In the end, the lifespan of planetary rings reminds us of the transient nature of the universe. These stunning celestial features, as they orbit in silent beauty, are subject to the unending cycle of creation and destruction. They are, in a sense, a cosmic metaphor for life itself. An ephemeral beauty, destined to fade yet eternally enchanting. From the delicate arcs of Neptune to the mighty Phoebe ring of Saturn, planetary rings never cease to amaze us. Each one is a marvel, a testament to the intricate and ceaseless dance of celestial bodies. We've journeyed together through the mysterious beauty of these rings, explored their origin, and pondered their lifespan. We've marveled at the rings of Jupiter, Saturn, Uranus, Neptune, Rhea, and even the distant dwarf planet Haumea. Yet, our journey is far from complete. With each passing day, new discoveries are made and our understanding deepens. The universe, it seems, is always ready to surprise us with more. There are still countless rings across the cosmos waiting to be discovered, each with its own story to tell. As we continue to explore, we look forward to unearthing more of these cosmic gems. In the grand theater of the cosmos, planetary rings play a captivating role, and the show is far from over. As we bring our interstellar journey through the awe-inspiring allure of planetary rings to an end, bear in mind, this is merely a tiny glimpse of the cosmic spectacle that awaits. Venture into the vastness of space will persistently lead us to even more celestial marvels. We invite you to accompany us on this thrilling exploration of the cosmos. If this cosmic voyage has imparted new knowledge and you've enjoyed it as much as we have, then be sure to hit the like button. Express your reflections and insights in the comments section. Your favorite ring system or a space-related subject you'd like us to delve into next? We are eager to hear from you. If you haven't yet, it's time to hit subscribe and ring the bell icon for keeping abreast with our newest content. Share this video with your network of friends and family, inspiring them with the beauty and enigma our universe encapsulates. As we continue shared exploration of the cosmos, remember each star carries a tale, every planet holds a mystery, and every ring sings a timeless ballad. Until our next cosmic journey, keep your eyes to the skies.